Hi everybody, welcome to our next video. Today we're going to be talking about imaginary numbers. An imaginary number is used as the letter I, and we define it as the value of I is worth the square root of -1. I is kind of like a placeholder because we know that we can't take the square root of negative numbers, but eventually we're going to do operations around the square root of -1. And we're going to use the placeholder of I as this value as we manipulate it and watch it disappear from the radical negative number to just the value of I. That'll make more sense when we go on. A pure imaginary number is written in the form bi, where the value of b is the real number, the number that we are allowed to manipulate, and I is our placeholder for the square root of -1. It's going to make more sense, I promise. Let's just move forward. The square root of 144, well, I know 12 times 12 is 144, or -12 times -12 is 144, but I can't find a value that gives me -144. So the way we manipulate this is that we separate this to -1 times 144. This square root of -1 could be given its own home. The square root of -1, we're going to use the placeholder I. And we know that the square root of 144 is just 12. Now we don't want to write it in this format. We want it to be the real number in front. So we're just going to rearrange everything and put the 12 in front and the I behind it. No, we can't take the square root of -144, but we can put a placeholder in the time being. Let's try this next one. Can't do the square root of negative numbers, so I'm going to separate them to -1 times 80. I'm going to give it its own home. Now the square root of 80 is not a perfect square, so I'm going to bust that up into two numbers that multiply to 80, where one of them is a perfect square. That value would be 16, and 16 times 5 gives me 80. Now we can start manipulating. Square root of -1 is the value of I. Square root of 16 is 4. Can't do the square root of 5, so I'm going to leave it as is. Now I've got I times 4 times square root of 5. This is imaginary times real, but we want it to be real times the imaginary. So we're going to rearrange everything and make it 4I radical 5. All right, next one. I don't like that square root of a negative number, so I'm going to put it as square root of -1 times the square root of 36 over the square root of 21. We can give them both their own home on top of each other, like they're in an apartment building. And square root of -1 is just I. Square root of 36 is 6. Square root of 121 is 11. But now we got imaginary than real, but we want it to be real than imaginary. So we're going to put it to 6 over 11 I. Okay, so all we've done is just simplifying radicals that we know how to do, and we're including this value of I now. So I mentioned that once we write in this way, when we put applications onto it, these exponents are going to adjust our I. Let's see how they change. I to the first power. Well, anything to the first power isn't going to change the value, so it's going to stay I. You could write square root of -1 if you want, but that just bumps back to I. The next one, square root of -1 times the square root of -1, because it's I squared. You can rewrite this as the square root of -1 to the power of 2. We know the duck principle cancels those ideas out. The square root being squared, those are opposite operations, and we just get -1. So that's the first element where our placeholder I is being eliminated and we're going back to a real value. This next one is kind of like if we rewrite it, I to the second times I to the first. We know that our product rule, we add the exponents. We know what I squared is. We just did it. I squared is -1. I to the first power is just I. -1 times I is -I. Do the next one. I to the fourth power. Well, that can be rewritten as I squared times I squared. We know I squared is worth -1. Multiply that by I squared, which is also -1. -1 times -1 is +1. This one here is like the OG rule. If you square I, it's like you're getting rid of that radical and you're getting 1. We're going to use that one a handful of times to move forward. We're actually going to use all 4 of these as we move on to the next one. I to the 5th power. Well, we can rewrite that as I to the 4th power times I to the 1st. Go steal what we know. I to the 4th power is 1. I to the 1st power is just I, and we get I. So I to the 5th is I. Keep going. I to the 6th is like I to the 4th times I to the 2nd. I to the 4th is worth 1. I to the 2nd, that's our OG, times -1. 1 times -1 is -1. We keep going like this. Oops, that should be a 3, huh? Because I to the 4th and I to the 3rd makes 7. So I to the 3rd is worth -I. 1 times -I is just -I. And last but not least, this one is I to the 4th times I to the 4th. I to the 4th we know is 1 times 1. We get +1. Cool. Now let's use all of these powers of I to simplify even greater values. I to the 11. We want to write it using one of these exponents as decomposition. So the power of 11, we can rewrite that as I to the 8th times I to the 3rd, because 8 plus 3 is 11. That's what our product rule does. I know what I to the 8th is. It's +1. And we're going to multiply that by I to the 3rd, which is -I. 1 times -I, -I. And we're done. We're going to, for a moment, ignore this -3. I'm just going to put it right here. We're going to try to decompose this I to the 20th. I can make that an I to the 8th to the 2nd power, and that's power rule. So that gets me to 16. What do I have left? I have an I to the 5th. So 16 plus 5 puts me at 21. Keep that -3 on the outside. I to the 8th is 1. I to the 5th was I. 1 squared is just 1. 1 times -3 is -3. Bring down your I, and you're done. Next one. 6 times 18 gives me 108. I to the 13 and I to the 3rd is I to the 16. We can rewrite that as I to the 8th times I to the 8th. I to the 8th is just 1. So right now we've got 108 times 1 times 1 gives me 108. All right, I'm going to do the rest of these without audio. Just going to have music underscoring. If you have a question about any of these, make sure you ask me tomorrow. Now we are moving on to dividing. To divide with complex numbers, you're going to multiply by I, or the conjugate, to rationalize the denominator. Just like we don't want any radicals on the denominator, we don't want any values of I, because what is I? I is the radical of -1. So that's basically a radical in disguise. It's imaginary, but it's not invisible. So we want to get rid of that. One way to do it is, if you see that I there, you can multiply by a fancy 1. I don't know if you guys remember this. A fancy 1, where it's just some number divided by itself, I'm going to multiply by I over I. If I multiply straight across, I get 6I over 7I times I is 7I squared. Remember, I squared equals -1. So this is really saying 6I over 7 times -1, and we get 6I over -7. And that is our final answer. Let's do the next one. We're going to multiply by a fancy 1. We're going to multiply by I over I, because when you multiply by 1, you don't change the equation at all. You're just making it look a little bit different. Multiply straight across. So technically, this is 8I squared. This one is I times 26, 26I, I times 4I, which is plus 4I squared. Okay, we're going to replace all the I squareds with a -1. That's what I squared is worth. So we have 26I plus 4 times -1 over 8 times -1, to which we get 26I minus 4 over -8. So we could leave it like that, but these are all values that have a common factor. We can divide everything by 2 to simplify. If you can simplify, you should always simplify. If I take a 2 out of everything, I get 13I minus 2 over -4. That's your final answer. I actually don't think that is our final answer. The reason being is because, look, they put the value of I in front. So I would argue, do I have any sticky notes? Let me see. Stand by. All my sticky notes are stained orange. Good. If you have room, you should rearrange this one to a -2 plus 13I over -4. The reason why, because we want it to be in that A plus BI format, where we want the I listed second. You go one step further too. If you don't like that both of these fronts are negative, you could factor out a -1 out of that too. And this is kind of like -1 times 4. So you can just change this to 2I minus 13 over 4. But if you put it like this, I would still give you credit. It's just really good practice, especially when you get to calculus, putting the I second. But in this course, at this point, I don't think I'm going to be that particular, so don't worry about it. Don't worry about it right now, but later, maybe, probably, definitely. Okay, these next ones. You're going to solve both of these the same way. I'm just going to do the harder one. You're going to do the easier one. So we could have multiplied by a fancy 1, or we can multiply it by the conjugate. The conjugate just says if you have a binomial, instead of it being minus, I'm going to multiply by the same idea, but with plus. So I'm going to multiply the top and bottom of this fraction by a fancy 1 still. Same thing on top, same thing on bottom. Instead of 1 minus 3i, we're going to do 1 plus 3i. The reason why I'm doing that, I'm not going to actually put this on my paper, but I'm going to show you that when you FOIL this, check this out. You're going to get 1 times 1 is 1. 1 times 3i is plus 3i. Negative 3i times 1 is negative 3i. Negative 3i times positive 3i gives me negative 9i squared. Check this out. The conjugate gets rid of the middle, plus 3i minus 3i, and we get 1 minus 9i squared, which we know is the same thing as 1 minus 9 times negative 1, and we get 1 plus 9. So that multiplying by the conjugate, oops, there goes my highlighter. This whole bottom part is going to give me 1 plus 3i minus 3i minus 9i squared, which eventually on the bottom is going to give me just the value of 10. Let's do the top real quick. If I FOIL out the top, negative 5 times 1 is negative 5. Negative 5 times 3i, negative 15i. 5i times 1 plus 5i. And 5i times 3i is 15i. Let's see what I can combine. I can combine this negative 15i with this 5i. Oops, I messed something up. That 5i times 3i is 15i squared. When those combine, I get negative 10i. So right now I'm at 5 minus 10i plus 15i squared, which we know is the same thing as 15 times negative 1. I'm running out of room, so I'm going to come up here. Now I can combine this 5 with this negative 15, and I get negative 10 minus 10i. If you look right here from this step down to this step, I forgot to bring down that negative. My bad. That's okay. I don't need to erase anything. Minus, bring the minus down, bring the minus over. I just forgot to bring my minus with me. So now I've got negative 5 take away 15 is actually negative 20. So you could be done here, but we know that we can reduce this. All these numbers are divisible by 10. So when I do that, I get negative 2 minus I as my final answer. When you do number 20, you're going to do the same thing. You're going to multiply by the conjugate. I'll set it up for you. 2 plus 6i over, under it, I guess. 2 plus 6i. So you're going to multiply that I into everything in there. All right, here comes part 2. So part 2 is complex numbers. When we are doing real numbers, adding, subtracting, multiplying, or dividing with the imaginary numbers. They're normally written as a plus or minus bi, where a represents the real number and bi represents the pure imaginary number. So we're going to start with addition and subtraction. We're going to combine any like terms. So looking at this first one, I'm just going to underline what looks like a like term. 6 is just a plain old number. Negative 8, plain old number. 6 plus negative 8 gives me negative 2. Then I've got this negative 4i and this positive 6i. And I add those together, I get positive 2i. And I'm done. So I can't combine any further because this one does not have an I and this one does. So I'm finished. What's highlighted in yellow is going to be your job to do later. So my advice to you for this one is don't forget to say negative 3 minus 4, 5a minus 6i. This negative applies to both of those values. All right, you're going to do number 12 as well. I'm going to do the harder version. Number 12 is just like the start of 13. So let's start with number 13 together. We're going to distribute everything in first. 6 times 3 is 18. 6 times 2i, we treat it like a variable. That's going to be 12i. Then we'll do the next one. We have a negative I being distributed to everything on the inside. Negative I times 5, I'm not going to say I5 because remember, we want it to be in the format of BI where the real number's in the front. So we're going to put negative 5i. A negative I times a negative 7i, that's a negative times a negative, which puts me at positive 7. I times I is I squared. Okay, let's see what we can move forward from here. We're going to combine like terms. I get 18 plus 7i. This one, I squared, remember? So we've really got 7 times I squared is the equivalent of negative 1. So that gives me negative 7. Then we have 18 minus 7. We can combine this value and this value now, and we get 11 plus 7i. And I'm finished. Remember, we want it to look like a plus bi, or somehow in this format you're in. You wouldn't want it to look like 7i plus 11. That's going to be all backwards on you. So make sure if you have a complex number, the I is at the end. Okay, so you're going to do 11 and 12 on your own. Alrighty, now we are going to be doing multiplication of complex numbers. Directions say to distribute and then combine like terms. So I'm going to skip 14 because it's actually more simple than the rest of them. You're going to do 14 on your own. Let's do this one together. I'm going to FOIL it first, outer, inside, last. So my firsts are the ones that are listed in front. I'm going to do 5 times 5 and get 25. Then the outsides, 5 times negative 3i gives me negative 15i. Then I'm going to do the insides. 3i times 5 is positive 15i. And our lasts, 3i times negative 3i gives me negative 9i squared. Okay, let's look where we can combine like terms. Both of these are the value of I. They actually cancel out because negative 15i and positive 15i, those go away. I'm going to bring down my 25. 9i squared. Well, I see an I squared, and we know that's going to be I squared. It gives me negative 1. So negative 1 times negative 9 is really plus 9. 25 plus 9, I get 34. Final answer. Okay, number 17. We're going to FOIL this first portion. We're going to distribute that second portion, and we're going to see what simplifies down. So let's FOIL it. Firsts, outers, insides, lasts. First is 7 times 6, and we get 42. Outsides, 7 times negative I is negative 7i. Negative 2i times 6 is negative 12i. And finally, negative 2i times negative single I, which would be a positive 2i squared. Good deal. So it's the end of FOILing. I'm also going to distribute this 3 into everything in here. 3 times 9 is 27. 3 times negative 5i is negative 15i. Let's see what we can combine. I've got a negative 7i, a negative 12i, and I've got this negative 15i. So we've got negative 7, negative 12, negative 15. All together gives me negative 34, I believe. Yeah, I think that's right. And we've also can combine this 42 and this 27. Get 69. The only thing that's left over is this 2i squared. But remember, I squared equals -1. So I have 2 times -1, which is just -2. I got more values I can combine. This 69 and this -2 gives me 67. Bring down your -34i. And that is our final answer. So when you do these two, think FOIL. Firsts, outsides, insides, last. When you do this one, it's written to the second power, so all you have to do is just write it twice. So it's kind of like you're just doing 3 minus 11i times 3 minus 11i, and you'll FOIL that out. Don't forget to simplify when you're done, or combine like terms. Okay. Now it is time to combine a lot of these ideas that we've been working on. So let's start with, how do you rewrite a negative radical? That's the same thing as -1 times 15. So we know that the radical of -1 is just I. And same thing with this one. It's going to be I times the radical 5. We're going to multiply the coefficients. I times I is I squared. 15 times 5 is 75. I know that I squared is -1. We can rewrite the square root of 75 as the square root of 25 times the square root of 3. Now we've got -1 times 5 square root of 3. My final answer is -5 root 3. Next one. Same idea. We're going to multiply the coefficients first, pull out i's. This can be rewritten as 2i radical 10. This one is -3i radical 2. 2 times -3i gives me -6i squared. Radical 10 times radical 2 is radical 20. This is the equivalent of -6 times -1. Bust that up to the square root of 4 and the square root of 5. -6 times -1 is 6. The square root of 4 is 2. And square root of 5, I can't do anything with that. 6 times 2 is 12. Bring down your radical 5. We cannot change that at all. I'm going to leave this one for you. I'm going to do the harder one. But this one is very similar. We're just going to distribute this into there, into here. Here we go. I'm going to multiply the coefficients by coefficients and the radicals by radicals. This first one, the 7, doesn't have any radicals, so the square root of -6 doesn't change. -4 times 7 is -28. -4 times -3 is +12. The square root of -6 times the square root of 12 is the square root of -72. These negative radicals can be pulled out with the value of I. So I've got -28i square root of 6 plus 12i. I could write square root of 72, but I can break that one up into the square root of 36 times the square root of 2. I get -28i radical 6. The square root of 36 is 6, so I've got plus 12i times 6 square root of 2. Got to rewrite that again. Running out of room. -28i radical 6. 12 times 6 is 72, positive 72. Bring up your I and leave your radical 2 at the end. we are finished. Okay. Next one. This one and this one are pretty much the same. Just remember, if you have a power of 2, you rewrite it twice. Okay, we are going to FOIL everything. The firsts, 3 times -8 gives me -24. 3 times all of that gives me 6 radical -3. Then I'll do the insides for the I. I've got a negative, there's a 1 here. -1 times -8 gives me +8, radical -3. And then my last one, -1 times +2 is a -2. Square root of 3 times square root of 3 gives me the square root of +9. And we're going to combine any terms that we're allowed to combine. This and this come together. So we have got -24 plus 14 square root of -3. -2 times the square root of 9. Well, we know that that is 3. So we've got -2 times 3 minus 6. So close to being done. This one and this one will give me, right? Yes, no, yes. Oh. Okay, well, I messed that one up. Okay. 3 times -8 gives me -24. 3 times 2 to radical -3 gives me +6. Yeah, +6 radical 3. And then we've got the insides, which is -1 times -8 gives me +8. Radical -3. That should be a negative, and this should be a -3. And then the last one, that one's a little tricky because we've got the square root of -3 twice. So whenever you have the square root of -3 times the square root of -3, that's like the square root of -3 squared. So it's going to wind up being -3. I also have a -1 times a 2, which would be a -2 times a -3. And so if we simple all this out, we get -24 plus, I can't have the radical be a negative, so I'm going to have 6i radical 3. Same thing over here. 8i radical 3. And this becomes +6. Looking for what I'm allowed to combine. A -24 and a +6 give me a -18. I'm just going to add the coefficients for these ones, leave the radical 3 alone. And I get 14i, +14i. And then I can't simplify anything else, and they're in the right order, so I'm finished with that one. And we're done. Do all the you do problems. Bye.